Class TV. I read myself Aliwi Tosin. We shall be taking elasticity. Today, what is elasticity? Elasticity can be defined as the ability of a substance to regain its original shape and size after being compressed or expanded by an external force. When an elastic material is being compressed when it's being compressed or expanded, the ability for the material to return back to its original position after compression or expansion is referred to elasticity. A good example of an elastic material is a spring or even a rubber. If you look at this now, when this spring, when there is a load exerted or applied to this spring as an external force, the spring extends. It extends like this, and the moment the force is removed, the external force is removed, the spring will do what? Will come back to its original position, and that makes the string an elastic material. An elastic material is any material that is capable or has the ability to regain its original position, original size or shape back after an external force is applied on it. So under this topic now, we're taking our external force as load. Like this is a load. So the external force there is a load, and load is a force that is measured in what? Measured in Newton. Load is a force that is measured in Newton. So this shows the word expansion, while this diagram shows what? Compression. When this body compresses the spring reduces in size. The moment the spring is released, that the load is taken off the spring does retain or regain its original size and an original shape back. Now, any point where the spring could not get back to its original shape back, then we say that it has exceeded its elastic limit. We get to that in the course of this topic. We get to that in the course of this topic. Now, before we proceed, there are some things I want to make known to us, because these are the things that will help us by the time we get to the level of calculation. Now, if you have this as a rubber of length, let me call this length L1, and that's the original length. If this length is 10 centimeter, now when you exert a force on it, probably someone drags the rubber. When you exert a force, what happens? The 10 centimeter length increases to, let's assume it increases to 12 centimeter. Are we together? To 12 centimeter. Now with this it means that our original length L1 is 10 centimeter, and our new length, this is new length now, after there is a force, that after the external force has been exerted on it, our new length is 12 centimeter. Now, we'll now be talking about extension. Extension is the difference between the new length and the original length after force has acted upon it. So we say that our extension E will now be our new length minus the original length. So for this case, our extension will be 12 centimeter, 12 centimeter minus 10 centimeter, which means that our extension, which is E, will be 2 centimeter. So we need to take note of this. By the time we are taking questions, you have to know when your question is referring to your original length L1, and when it's referring to to your new length L2. And when you are talking about what? Extension E. Now let's take Hooke's law. Hooke's law talks about the relationship between the extension E and force applied. Now, from our previous explanation, we'll be able to make it known to us that when the force that is applied to an elastic material is released, the elastic material moves back to its original position, original size or shape. Now, Hooke's law now talks about the relationship between the extension E, which is different between the original length and the new length after extension, and the applied force or load. Now, Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension E of the elastic material is directly proportional to the applied force or load. Provided the elastic limit of an elastic material is not exceeded. What is the elastic limit? That is the point where it's impossible for the elastic material to come back to its original position again, or it's a point where the extension is not directly proportional to the force or load on it again. So we say that the Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension E of the material is directly proportional to the applied force or load. Now, by formula now, it means that we are saying that force is directly proportional to extension E. And from constants, from relational, we can say that our F is equals to K E. Where our K here is the elastic constant. Our K here represents the elastic constant. Now, while K represents the elastic constant, we can also say that the elastic constant can also be referred to as the stiffness of the material in question. Stiffness of the material in question, because to determine how elastic a substance is, to determine the degree of extension of a substance, this depends on the stiffness of the substance. How far we can extend our normal rubber band is different from how we can extend the belt. That's a grinding machine belt. It is still an elastic material, is a rubber, but one is thicker than the other, and that is about the stiffness. So before we could go further in determining the extension or the force applied, we need to know the stiffness, that the elastic constant of a given elastic material. So we say our F equals to Ke, where F is the load or applied force, and we have our E as the extension, and our K, like I said, is the stiffness or elastic constant. From this now, we can say that our F, which is equal to Ke, if we divide through by E, which is extension, it means we can say that our K is equal to our elastic constant now is equal to force over E. That's force over extension. Now, if our elastic constant is force over extension, then we can say that elastic constant is measured in elastic constant is measured in what? Our F here is Newton, and our E here is is measured in meter. So elastic constant is measured in Newton per meter. It's measured in Newton per meter. So that is what Hooke's law is saying. So I think we stop there for today. In our next class, we'll be taking verification of Hooke's law. Verification of Hooke's law. Thank you. I name myself Alewi Tosin.